Hello everybody, I hope that all of you are doing well. This is lab number 8, and in lab number 8 guys we will study the static equilibrium. So for this simple experiment guys, what do we need? We need a balance, as you can see right here. So this is a balance. And also we need set of weights, as you can see right here. So you have 1, 2, 3, 4, 5, 6. Okay, and here we have meter stick. So this is a meter stick. I provided the meter stick with this simple tool so that can help me guys to balance the meter stick. So okay, so that's very nice. And another hook, I will use this hook as well guys to balance the meter stick. So we need to have the system connected like this, and I will show you how we can do that. And of course I will use a holder for this system. So this is very nice. Now guys, what I'm going to do, I'm going to show you the weights of each one of these masses. So you can see that mass number 1 has 117.5 grams. So we have maybe I need to cover this light, so maybe this light prevents you from seeing that number. So we have 117.5 grams. So that's very nice. And also we can double check here to make sure that we have this weight. I'm going to come here, so 117.5. So this is very nice. And then come to mass number 2. So this is mass number 2, and I'm going to cover this light. So you can see that mass number 2 is 125.5 grams. 125.5 grams. This is very nice. I will have it right here. And then I will move to mass number 3 and show you the weight of mass number 3. I weighed all of these guys before recording the video. So we have 119 grams. 119 grams. This is mass number 3. So 119 grams. Maybe we need to double check here. So 119 grams. This is very nice. And also mass number 2, just to make sure everything is going very well. So 125.5. That is very nice. And now I will move to mass number 4. So mass number 4, as you can see guys, is 127.5 grams. 127.5 grams. This is mass number 4, and you will have it here. So we need to wait for some time. So 127.5, it looks like 128 here. But I will try to zero the balance. Double check. So that's very nice. I will now measure the mass. So it looks like guys 128, but what I have here is 127.5. So I'm going to change that and I will write that down here. So I have 128 grams. I will ignore this. So again, this is mass number 4, and mass number 4 is 128 grams. 128 grams. That is very nice. And then I will come to mass number 5, and mass number 5 is 120.5. 120.5 grams. And I will measure mass number 5 and see what do we have. So 121. Wait for some time and see what will happen. Yeah, so remove this, zero the balance, and then measure this again. Yeah, so yeah, 121. So I will consider, guys, 121 grams. So that's very nice. So just consider 121 grams and ignore this one right here. So now I will cover the balance light. So now, guys, you can see that we have 121 grams for mass number 5. 121 grams for mass number 5. This is very nice. And I will move now, guys, to mass number 6. And what I measured for mass number 6, I measured 327 grams. 327 grams. I will measure mass number 6 and see what do we have now. 327. So what I have here, I have 326. Okay. Maybe I will have the mass here and then zero the balance and then measure everything again. So 325. 325. Remove it and measure it again. So 325, 325. Remove it and measure it again. So 325, 325. Okay. Yeah, and my advice here, always keep the balance like on top of a solid table, so that can help the balance to give you correct measurements. So I will write that down. So now we will have 325 grams instead of 327. 325 grams. So that's very nice. This is for mass number 6. So for mass number 6, guys, we have 325 grams. 325 grams. That's very nice. And now I'm going to measure the meter stick. So I will measure and figure out the mass of the meter stick. So let's do that and see what do we have here. So for the meter stick, guys, we have 71.5 grams. 71.5 grams. And I will write that down somewhere on the meter stick. So maybe I will write that down right here. So I have 71.5 grams. So 71.5 grams. 71.5 grams. So that's very nice. This is the weight of the meter stick. So you have 71.5 grams. Now we weigh everything, and I think we are ready now to start the experiment. And I will show you guys what we are going to do in this experiment. Actually, I will follow the lab manual, so I will do exactly as we have in the lab manual. So let's get started, and I will show you what we are going to do right now. Okay, so this is what we are going, guys, to do, and I got all of these information from the lab manual. So we need, guys, to do two parts, part number 1 and part number 2. Actually, in part number 1, guys, we need to set this system that you can see right here. Before we set this system, we need to balance the meter stick without adding weights and see the center of mass of this meter stick. So this is the first thing that we need to do. And after that, we need, guys, to add mass number 1 at certain distance from the center of mass, and then try to add another mass and move this mass forward and backward, or increasing the mass, for example, or decreasing the mass to achieve the balance. And create system number 1 with M1, X1, M2, X2. And then change mass M1 and change X1 and add another mass right here, and move this mass forward and backward, and maybe adding mass or decreasing mass to achieve the balance. So this is set number 2, or trial number 2. And then, guys, do that for the third time. So choose different mass here. So M1 would be a different mass, and then choose different X1 also, and try to add another mass, adjust that mass, the position of that mass, and also the mass itself to achieve balance, and that will give you different X2. So that's set number 2, or trial number 2. So we have 1 trial, 2 trials, and 3 trials. We will do 3 of them, guys. Then, guys, what we are going to do, we are going to study the sum of torque about 0.0 centimeter, which is this point right here, and then about 75 centimeter. So we'll study the torque about 75 centimeter and do the same thing that we do in today's session. Okay? And also here, guys, we need to use this idea that we did before, guys, to find the mass of object with unknown mass. So since we did that 3 times, so we made a balance, and this balance should be good to measure the mass. So we can now, guys, have known mass, which is mass number 1, and have that adjusted at distance x1 from the center of mass, and add the unknown mass, which will be mass number 6, here. So mass number 6 would be the unknown mass. I will use this. Okay, so we'll use the unknown mass and have it right here and try to adjust the unknown mass to achieve x2 that give us equilibrium for this system. So this is very nice. So we just made the balance here. And the last thing that we need to do here, guys, so then we need to use the balance that we have right here, then use the balance to find the mass, the unknown mass, and then compare between the measured mass using the equilibrium idea with the mass that was measured using the balance and see the difference. So this is everything, guys. This is what we are going to do today, and let's go through that step by step and see what we can do. Okay, so that's very nice. Okay, everybody, as you can see right here, so you can see that I balanced the meter stick, and you can see here that we have 46.4 centimeters. So 46.4 centimeters. Now I will go back just to show you that this meter stick was balanced. So you can see the whole meter stick. Okay, so let's go back, continue to go back, and continue to go back. So we can move a little bit to the right, so you can see this end, and a little bit to the left, so you can see this end, and this is the meter stick balanced, as you can see. So this is very nice. Let's move now to the next step. Okay, as you can see, guys, that now we have set number 1, and in set number 1 we have two masses with the meter stick. I have mass number 1 that you can see right here. It is 117.5 gram, and if you go a little bit up right here, you can see that we have 10.1 centimeter from the zero right here. So that's very nice. So we have 10.1 centimeter. So this mass is located at 10.1 centimeter. Now I will move to the other mass. It is right here, and you can see, guys, that this mass right here, you can see that we have this mass right here. It is 119 gram plus 125.5 gram. So this is mass number 2, and you can see that mass number 2 is located exactly at 63.5 centimeter from the zero. Okay, so this is very nice. This is set number 1, and it is balanced. I will go back slowly now to show you that the whole system is balanced, as you can see. So the whole system is balanced. So you can see that we have mass number 1 right here, and mass number 1 right here, and mass number 2 right here. Maybe I will move a little bit to this side so you can see mass number 2. Yes, there it is. This is mass number 2, and this is mass number 1, and it is balanced. So that is very nice, guys. And if you go here, so you can see that the whole system is balanced, as you can see. So the whole system is balanced. So this is very nice. This is set number 1. It is a little bit hard to balance this kind of system, but yeah, I'm sure you can do that, guys. So this is set number 1. Let's move now to set number 2 and see what we can do. Okay, everybody, so here we have set number 2 or system number 2. So I added mass number 1 to be 117.5 plus 121, so 117.5 gram plus 121 gram plus 128 grams. So this is mass number 1, and it is at 20 centimeters. And in the other side, right here, so I have mass number 2, and mass number 2 was changed to be it wasn't changed, it is still 119 gram plus 125.5 gram. And I just moved this mass forward and backward to achieve the balance. And I noticed that the balance happened when mass number 2 located at 85.7 centimeters. So that's very nice. Okay, now we will do set number 3 together, just to show you how to balance this system. We didn't do that with system number 1 and system number 2, but we will do that with system number 3, just to show you how to balance the whole system. So right here, guys, so this is mass number 1, and mass number 1 is 117 plus 121 gram plus 128 gram, and here we have 170 grams. So this is mass number 1. That's very good. And here I have mass number 2, and mass number 2 is 325 grams. 225 grams. So what I do, guys, I do something like this. So we can see that the meter stick can move if I try to rotate this meter stick. So I'm going now to move this mass maybe at 17. So I will choose 17 centimeters. So exactly 17 centimeters. That's very nice. And I will come now to the other side and have mass number 2 hanged here. So this is mass number 2. But you can see, guys, that it is really hard to balance this system. So I need to move this mass a little bit to the left, a little bit to the left, a little bit to the left, a little bit to the left. Now carefully move this to the right. Let's see, again carefully move this to the right, carefully move this to the right, and again carefully move this to the right, again to the left. So I didn't show you that when we do system number 1 and system number 2, because that will take a long time. So you can see here there's no balance. Need to continue doing that. So we'll move this a little bit to the right. Okay, kind of balanced. A little bit to the right. A little bit to the right. It's very good. Now everything was balanced, and this is very nice. I will now focus on mass number 2 and see exactly what do we have. So we have 79.2. So we have 79.2 centimeters, and it will come here now, okay, and see what do we have. So we have exactly 17 centimeters. So I will write that down. So we have 17 centimeters. And again, to remind you, here we have 117.5 gram plus 121 gram plus 128 gram. And on this side we have 325 gram. and we achieved the balance with 79.2 centimeters on this side and 17 centimeters from the other side. So this is very nice. Now guys, we will move to the next step, which is to try to measure the mass of like object with unknown mass. So let's try to do that. Let's move to the next step. Okay, now we will try to measure the mass of object with unknown mass. I don't know the mass of this object, but I know the mass of this object, so I have 325 grams, and I will use this idea, summation over torque is equal to 0, to figure out this mass right here, and I'm going to do that right now. So let's do this. I will start. So this meter stick was balanced at the center of mass, so this is very nice. I will now move this unknown mass maybe around 15. Yeah, I can choose 15, that's fine. So 15 centimeters, and then have this mass on the other side and do the same idea. Try to balance the whole system. So I will move this mass a little bit to the right, a little bit to the right. It's not balanced, so I will move it a little bit to the left. Looks like, yeah, it's not balanced. Move it a little bit to the right. Wait for some time. Okay. It looks like balanced, guys. So I can move this a little bit and see if it was balanced. Yes. So it was balanced, guys. This is very nice. I don't need to disturb this. Let's have the positions before I destroy everything. So let's do that quickly. So I will come here and see that I exactly have 15 centimeters from this side. So 15 centimeters, as you can see right here. And I will move now to the other side and see what do I have. I have 77.5, 77.7, 77.8, 77.8. This is what I can see, guys. 77.8. So right here we have 77.8 centimeters. Again, just to remind you, here we have 325 grams. Here we have unknown mass. I don't know the mass of this object right here. I will try now, guys, to use the idea of summation over torque is equal to 0 to figure out the unknown mass. So this is very nice, and now we will move to the balance and just measure the mass of this object to compare between this system and the balance that we have. So let's go there. Okay guys, this is the unknown mass that we just used in with the system number 3 in part number 1. I will try now to use the balance to measure it, and then I will compare the mass that is measured with the balance, okay, with the mass that's measured using this idea right here, which is summation over torque is equal to 0. And once I measure this unknown mass, we will move to the whiteboard and show you all of these calculations, guys. So don't worry about that. Let's now start the balance. Make sure that the balance is working. It looks very nice. I will now have the mass, the unknown mass, which is right here, and have it here slowly, and see what do we have. We have a 325 gram. Oh, it looks like similar to this one. So we have 325 gram. Yeah, I don't know that, but yeah, that looks interesting. We will see that. We'll see if we get 325.5 gram. So the unknown mass is equal to 325.5 gram. Okay, now let's move to the whiteboard and finish the whole work together. Let's go there, guys. Okay, let's now try to see the data that we collected from today's experiment. So from today's experiment, we did like 3 different systems. So meter stick and 2 masses, as you can see. We hang the meter stick from the center of mass, which is right here. So we have X center of mass is equal to 46.4 centimeter, and the same center of mass here for the meter stick, the same center of mass for the meter stick right here, and you know that this is the 0 of the meter stick, this is the 0 of the meter stick, and this is the 0 of the meter stick. So X1 that we have right here actually measured from 0 to this point where mass number 1 is hanged, and X2 is measured from 0 to this point where mass number 2 hanged, and the same thing with system number 2 and the same thing with system number 3. So yeah, we repeated the same story like 3 times with different masses, of course, and different distances, x1 and x2. And if you'd like to figure out this distance, for example, you need to subtract x1 from the center of mass point, so that will give you x1. And if you'd like to get this distance, which is from here to here, you need to subtract the center of mass from x2, so that will give you this distance right here, and that can be applied here and here and here. Okay, I'm going to go to the lab manual and show you guys this part. So let's do that. So this is the lab manual. I will go to the experiment. So where is the experiment? Experiment number 8. So this is experiment number 8, guys. And if you go right here, I don't know if you can see that, but if you go right here, guys, you can see that the lab manual will ask you to repeat this step another 2 times. Okay, so you can see here, repeat steps 3 and 4 for 2 more different sets of values of M1, M2, and X1 and X2. And this is what I did, guys. I did that once and repeated that twice. Okay, so you have the whole data that you need for this part right here. That's very nice. And also, guys, you can do this part as well. That's totally fine. So you can do this part. It is asking you to get the pivot point or the reference point at 0 and then at 0.75. So you can do that, guys, and finish this part right here. So And just I would like to mention that what I used is actually is not meter stick, so it is around 90 centimeters. So the whole length of this stick that I have is 90 centimeters. So keep that in mind. The center of mass for this stick is 46.4 centimeters, which is what we have right here. Okay, that's very nice. So we have the whole data that we need right here. So go through the lab manual. So go through the lab manual, guys, and when you go through the lab manual, you will see that you will need this data to finish the first part. Now if we come to the second part, you will see that the lab manual is asking you to have unknown mass. This is the unknown mass that I have. So here we have unknown mass. Here we have known mass. And I have the whole data that you need, guys. I have M, unknown mass, M2, 325 gram, X1, 15 centimeter, X2, 77.8 centimeter. And also I measured the balance to measure the unknown mass. So you can benefit from that. So you can use the idea of equilibrium, static equilibrium, to figure out M, and then compare M right here with the M that was measured with the balance. So that is very nice. This is the whole data that you need, guys, for this lab. I believe now you can start working. And I will just mention that so how precise my meter stick is. Actually, guys, my stick right here can measure. So you can use that, guys, as an error. So when you try to calculate the error, you need to keep that in mind. So you can see that the smallest value that my meter stick can measure is 0.5 centimeter. So what I did, guys, I just divided this 0.5 centimeter to 5 millimeters. Okay, so when I divided that to 5 millimeters, now my stick became able to measure smallest value as small as 1 millimeter. So you can use 1 millimeter and use the idea of the single measurement uncertainty. Okay, so yeah, now you need to divide 0.1 millimeter by 2, and that will give you guys the uncertainty from the meter stick. From the balance, so the balance, guys, the smallest value that the balance can measure is 0.1 gram. So this is the smallest value. So you can use this value to calculate the single measurement uncertainty. So yeah, delta M is equal to 0.1 gram divided by 2. So that will give you the uncertainty from the balance. Okay, so you have the uncertainty from the balance. You have the uncertainty, guys, from the stick. So I believe you are ready to work. And I know maybe the experiment has other other things that can increase the uncertainty for the final results here, but let's try, guys, to do the calculations and see what will happen. So for me, guys, I tested this. I got exactly the same mass, which is very nice. I did this part right here. I tested this part, and also I tested this part, guys. So I had the reference point at the center of mass, and then apply the same idea, the right hand idea. So we have R cross force, and so the torque from this force is in this direction, and we have R and we have force, so the torque is in this direction, so this is equal to that, and you can see that, guys. Yeah, the summation over torque here is equal to 0. So try to do that, okay? And this is the data for set number 2, and this is the data for set number 3. And this is the data that you need for the final part. So thank you so much, guys. I did my best to include everything, include all of the details that you need. Now I will move a little bit, before I stop the recording, I will move a little bit to this side so you can see the whole data here. So I will keep that for some time. Maybe you can take a picture or stop the video and start writing this data down. Okay? Again, thank you so much and see you next time, guys. Bye-bye.